Questions 21 to 25 of the 2000 Grade 10 AMC 10. If all alligators are ferocious creatures and some creepy crawlers are alligators, which statement must be true? All alligators are creepy crawlers. Some ferocious creatures are creepy crawlers. Some alligators are not creepy crawlers. All right, something called a Venn diagram is what I will draw. And if you're not familiar with a Venn diagram, it's not a problem. I can easily explain it. Basically, I'm trying to put these statements together. So our first scenario and our second scenario, we're trying to match them somehow. All right, so let me explain what I drew here. In this blue circle, I have put all of our ferocious creatures. All right. In the red oval, I have put all of our alligators. And in our orange circle, I have put the other entity, which is creepy crawlers. So I'm going to write that in without making it too messy. Okay, so I just wrote the initials. So now let's work with this here, one by one. All alligators are creepy crawlers. Well, that's not true, right? This region, the alligators are creepy crawlers. They're part of that orange circle. But outside, they're not. So one is not true. So wrong. How about number 2? Some ferocious creatures are creepy crawlers. Well, the ferocious creatures circle and the creepy crawlers circle has an overlapping region right here, right? So that means, yeah, some ferocious creatures that are in that region are also creepy crawlers. So that's true. How about number 3? Some alligators are not creepy crawlers. Some alligators are not creepy crawlers. Now this is the part of the question that is tricky, I think. That the way I drew it, you think, yeah, well, it makes sense. Some alligators are not creepy crawlers. These guys right here, outside of that. But that's just the way I drew it. What if all were equal? Our ferocious creatures were equal to our creepy crawlers, were equal to our alligators. Then the Venn diagram would look like what? If all three were equal, meaning the number of ferocious creatures is equal to the number of creepy crawlers is equal to the number of alligators, our Venn diagram basically becomes 3 overlapping circles. And therefore, this statement would not be true. Some alligators are not creepy crawlers, where in this one, all alligators are creepy crawlers, right? Because they're equal. So some alligators are not creepy crawlers would not be true. Correct? So I've created a scenario in which statement number 3 is incorrect. And we had already made statement number 1 incorrect in this. So now we have to see if statement number 2 holds up in this scenario. Some ferocious creatures are creepy crawlers. Yeah. In fact, all of them are. Some are, and all of them are. So this still holds true. So therefore, the only one that's true is 2. So therefore, that's B as the answer for number 21. Tricky question. One morning, each member of Angela's family drank an 8-ounce mixture of coffee with milk. The amounts of coffee and milk varied from cup to cup, but were never 0. Angela drank a quarter of the total amount of milk and a sixth of the total amount of coffee. How many people are in the family? All right, I'll let n equal the number of people. And since each member drinks an 8-ounce cup, the total amount of ounces that everybody drinks is 8 times N. Total amount that is consumed by the members of the family. Now let's start with the fact that everybody's got some coffee and milk. So the total amount of coffee and the total amount of milk is going to equal this 8N. All right, so that's our first equation. Our second equation involves Angela. And they tell us that Angela drank a quarter of the milk, total milk, so M over 4. And she drank a sixth of the total coffee, so C over 6. And she is one of the members of the family, so she drank 8 ounces. And that's equation number 2. So these are the two equations we have to work with. All right, so here we go. So I always want to eliminate at least one variable. So let's see here. First, let's multiply this here through so that we can get rid of the fractions. Let's multiply it through by 24. So if you do that, you'll get 6M plus 4C is 192. And I'll call this 2. It's a better equation to work with because you don't have fractions. All right, so let's use 1 and 2. And so I'll do 2 minus 4 times 1. I think that will help me get rid of at least one of these variables. So we'll have 6M plus 4C minus 4C minus 4M is equal to 192 minus 32, like that. 32N, sorry. And this looks like these cancel, so we got 2M is equal to 192 minus 32N. And therefore M is equal to 96 minus 16N. And M is representing the amount of milk. Now M is never 0. The amounts of coffee and milk varied, but were never 0. So M is not 0. M has to be greater than 0. So if M is greater than 0, that means that this is greater than 0. So that means that 96 minus 16N is greater than 0. And therefore 96 is greater than 16N, and therefore N is less than 96 over 16. And that means that N is less than 6. So N, it represents the number of people in the family, and it's less than 6, so we can get rid of choices D and E. So they're only giving us 3, 4, and 5. All right, let's work with 3, 4, and 5 for N. So N is either 3, or it's 4, or it's 5. Okay. So how do we figure out which one of those 3 is N? Well, we have to, again, use our formulas, our two formulas. Our two formulas were this one and this one right here. So C plus M is equal to 8N, and 6M plus 4C is equal to 192. All right, let's start with N equals 3. So if N equals 3, we have C plus M is equal to 8N. So 8 times 3 is 24. And then therefore we have 6M plus 4C is equal to 192. Correct? And then of course we can subtract 4 times this equation from this equation, and that would give us 6M plus 4C minus 4C minus 4M is equal to 192 minus 96. The C's are gone. 2M is equal to 96, and therefore M is equal to 48. But M can't equal 48. C plus M is equal to 24. So if M equaled 48, C would equal minus 24. So this is not a solution. So M cannot be 3. So we got rid of 3. Now we're just down to 4 and 5. So let's see what we get for n equals 4. This was n equals 3. N equals 4. Using that equation, we get c plus m is equal to 32. And then, of course, we have this 6m plus 4c equals 192 to help us out. Again, multiply this by 4 and then subtract. We'll get 6m plus 4c minus 4c minus 4m. We got 192 minus 128, I believe. And that would be 2m is equal to 64, and therefore m is 32. Well, if m is 32, that would mean c is 0 using this equation. But c cannot be 0 because remember in the question they said that the amounts of milk and coffee are never 0. So n cannot be 4. So by process of elimination, n is 5. But let's just do it. C plus m is going to be 8 times 5, which is 40. Then we have our 6m plus 4c is 192. And then we can multiply this by 4 and subtract. So we get 6m plus 4c minus 4c minus 4m. And that would be 192 minus 160. And that would give you 2m is equal to 32. M is equal to 16. And therefore c would be equal to 24. And those are valid numbers. So therefore n is 5. There's 5 people in the family. And that would be choice C. When the mean, median, and mode of the list here are arranged in increasing order, they form a non-constant arithmetic progression. What is the sum of all possible real values of x? Okay, so mean, median, and mode. All right, first and foremost, what is the mean? Well, the mean is just the average. So 10 plus 2 plus 5 plus 2 plus 4 plus 2 plus x all over 1, 2, 3, 4, 5, 6, 7. And this just looks like 25 plus x over 7. So the mean is always going to be 25 plus x over 7. Median. What is the median? Well, the median is the middle value. Well, what is the middle value? Well, first, let's arrange the numbers from smallest to largest. So we get 2, 2, 2, 4, 5, 10. But we don't know what x is, right? So we've got some scenarios here. The first is if x is less than 2. If x is less than 2, then we would be arranging it in this order. X, 2, 2, 2, 4, 5, 10, like that. And the median would be the middle number, which is this one right here, 2. If x is, say, greater than 2, but it's less than 4, then our numbers would be arranged like this: 2, 2, 2, x, 4, 5, 10. And then the median in this case would be x. And if x is any value greater than 4, then we would arrange it like this: 2, 2, 2, 4, and the x would be somewhere. We don't know, but it doesn't matter where the x is because the median would then just be 4. 4 would become the middle number. So for median, it was a little bit more complicated. We got 3 possibilities. How about the mode? Mode is the most common number. Well, on this list, the most common number is 2, and thankfully the mode is always going to be 2. Even if x is 4, it still wouldn't become the mode. Even if x is 5, it still wouldn't become the mode. All right, now they're going to arrange this in increasing order, and it then becomes an arithmetic progression. So what does that mean? First, let's put it in increasing order, and then we'll talk about this arithmetic progression. So we've got three scenarios. Scenario 1, 2, and 3. In increasing order, let's go with the first one. And when x is less than minus 2. When x is less than minus 2, our median is 2, our mode is 2, and our mean is 25 plus x. So mean, median, and mode become 25 plus x over 7, 2, and 2, right? But this is not an arithmetic progression, and I'll explain a little bit later. Let me just fill this out first. How about scenario number 2 when x is between 4 and 2? Well, our median is x, and our mode is 2, and our mean is 25 plus x over 7. And then finally, in our last scenario, when x is greater than 4, our median is 4, mode is 2, and the mean is the same. All right, now let's talk about arithmetic progressions. An arithmetic progression is a series of numbers of this form: a plus d, a plus 2d, like that. So for example, if a was, say, 5 and d was 3, it would be 5 plus 3, 5 plus 2 times 3, and so on. A plus 3d, and you get the point. 5 plus 3 times 3. So it was 5, 8, 11, 14, and so on. That is what is known as an arithmetic progression. So we have to show, first of all, can this be an arithmetic progression? And if so, what is the value of x? Now, one thing that they noticed, or I noticed, is that they want you to put them in increasing order, and only then does it form a arithmetic progression. Okay, put them in increasing order. Well, first of all, the first one is not an arithmetic progression, right? Because the numbers have to kind of keep increasing, and we've got two numbers that are the same. So this is not a possibility. So that's good. We only have to deal with case number 2 and case number 3. So get rid of those. Now we have to look at case number 2. And case number 2, we want to put it in increasing order. Now, when did case number 2 occur? It occurred when x was between 4 and 2, right? So if it occurred between x is equal to or less than 4 and greater than 2, that means that this is the smallest guy. So it would be like this: 2, and then x, because x is greater than 2, and then 25 plus x over 7 is probably the largest. So this is an increasing order. Okay, so this is scenario number 2. Now scenario number 3, when did that happen? It happened when x was greater than 4. Okay, so if you put that in increasing order, you'll have the 2, then the 4, and most likely that is going to be the largest one. It makes sense, right? So now we have to figure out x. So how do we figure out x? What's the formula? That's when this arithmetic progression information comes in. In any arithmetic progression, if you take the second term and subtract it from the first term, it will be equal to the difference, which is d. And same thing, if you take this third term and subtract it from it, the second term, minus a minus d, it would equal d. So anytime you have an arithmetic progression and you take two terms and subtract them, it will give you d. So that is what we have to do with these. And we'll do that one at a time. So that means that for the first one, 25 plus x minus 7 subtract x is equal to x minus 2. All right? So that is basically why they told us it's an arithmetic progression, because it helps us. So now let's solve for x. Let's multiply through by 7. So that would give you 25 plus x minus 7x is equal to 7x minus 14. This looks like 14x minus x, which is 13x. This looks like 39, so therefore x is equal to 3. Great, we got one value. Now let's use the same principle on the third scenario. 25 plus x over 7 minus 4 is equal to 4 minus 2. Correct? So we got 2 is equal to, bring the 4 over, plus 4, 25 plus x over 7. So we got 6, cross multiply 6 times 7 is 42, 25 plus x, and therefore x is 17. So there you go, you got your two values. Now what is the question asking us? What is the sum of all possible values of x? Okay, so x was 3 and 17. So the sum of all possible values is 3 plus 17, which is 20. So the answer to number 23 is E. Let f be a function for which f at x over 3 is equal to x squared plus x plus 1. Find the sum of all values of z for which f at 3z is equal to 7. All right. So f at x over 3 is equal to x squared plus x plus 1. And now they want you to find this whole f at 3z. Now, f at 3z is representing x over 3. So 3z is representing x over 3. So I have to figure out what is x. So that means that x is equal to 9z. So that's what I'm going to plug in for the value of x into this equation. So 9z squared plus 9z plus 1. And f at 3z, they told you, is 7. So there you go. That's our equation. And this most likely is quadratic, so probably going to have to use a quadratic equation, quadratic formula. So this becomes 81z squared plus 9z minus 6, like that. And I think we can simplify this a little bit, divide through by 9, and that would give you 9z squared plus z is 6 over 9, or 2 over 3. And at this point we have to use our quadratic. So z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, like that. So this becomes negative 1 plus or minus 1 plus, this looks like 3 times 2, 6 times 4, 24, positive 24, like that, all over 18. So this is negative 1 plus or minus 5 over 18. So that's negative 1 plus 5 over 18 and negative 1 minus 5 over 18. So that gives us 4 over 18 and minus 6 over 18. And what is the question asking? Find the sum of all values of z. Okay, so we got to add them up. So these are all our two values of z. So the sum would be 4 over 18. Add to it minus 6 over 18. And that looks like minus 2 over 18, which is negative 1 over 9. So the answer is negative 1 over 9. And that would be choice B. In year n, the 300th day of the year is Tuesday. In year n plus 1, the 200th day of the year is also Tuesday. On what day of the week did the 100th day of year n minus 1 occur? So the first thing I'm going to do is draw out a little bit of a calendar for this question. And let's start filling in our values. So the first thing they tell you is that in year N, the 300th day is a Tuesday. So the 300th day is this Tuesday. And we have to kind of work from there. So therefore, 301 is Wednesday, 302 is Thursday, 303 is Friday, and so on, right? Like that. But obviously, we're not going to plug them all in. We can go and keep adding sevens, because every 7 days it's going to be a Tuesday. So if we do that, you can easily do that in your calculator. Just type in +7 and just keep hitting equals. It'll get to 363. So that means the 364th day is a Wednesday, 365th day is a Thursday. And then after that, we get into the next year, which is year N plus 1. 2, 3, 4, like that. 5, 6, 7, 8, 9. Now, of course, we don't have to keep doing this. We just want to get to day number 200 and ensure that it is indeed a Tuesday. So similarly, you can just keep adding 7 to this 8 here. And if you do that, you'll eventually get to ... 197. And therefore, this is 198. And this is 199. And then therefore, this is 200. So the 200th day is a Monday. But the question told you that the 200th day is Tuesday. So what happened here? What did I do wrong? Well, I didn't do anything wrong. I just wrote 365. The only way this can work is if we have one additional day. That means that year N is a leap year. And as you know, leap years have 366 days. So everything gets shifted over. This is now 366, and this is now 1. And you see what happened? And that is how we can make this question work. This becomes 7, this becomes 8, and so on. And then therefore, if we keep adding, this becomes 197, this becomes 198, this becomes 199, and finally our 200th day is indeed a Tuesday. All right? So that's the first part of the question. Now we got the second part of the question, which is what day of the week is the 100th day of year N minus 1? All right, so now we got to go backwards. Well, the good news is that year N is a leap year, so year N minus 1 is not a leap year, right? Because leap years come every 4 years, not a leap year. So N minus 1 has a standard 365 days, okay? So now we got to work backwards from 300. And similarly, if you just keep going backwards from 300, you, by a fact multiples of 7, you'll eventually get, 293, and so on, ... like that. You can do it in your calculator. You can subtract by 70 too to speed up the process. And if you do that, you'll get down to 13, and then you'll get to 6. So then you'll have 5, 4, 3, 2, and 1. And therefore, the Wednesday will be 365 of year N minus 1. But they want the 100th day. All right? So same thing. You got to keep going backward from 365, and you can always subtract by 70s. And if you do, you'll get all the way down to 106. All right? So you got 105, 104, 103, 102, 101, and finally 100. And that 100th day is a Thursday. So the answer to 25 is A.